This is a figure that IPCC created around the year 2010 or so, and it showed the, or 2005. It showed the type how climate was studied in the mid-70s when I was a student. For example, the climate models were atmospheric models. And then in the mid-80s, we coupled with land surface, and in the mid-90s, we added the ocean, and sea ice, and so on. And it was very, very important to couple the atmosphere and the ocean, for example, because when we didn't couple the atmosphere and the ocean, we could not predict El Niño and southern oscillation. And the person that was showing it with pride that we have such a complete modeling system, but if you look, it doesn't have the human system. So we are still missing the most important component of the Earth system, which is the human system, which dominates. So this is what we should be doing. And amazingly, except for a study, a very prescient study by Brotherton and colleagues at NASA, there was no attempt to couple or to point out the need of coupling or the human and natural system. So we developed this schematic, which shows the Earth system on the left with, for example, a global atmosphere, which has temperature, wind, fluxes, rain, etc., CO2, and the land, an atmosphere, land, and water component, and the land has vegetation that is dynamic, so it grows forest or grasslands or deserts, depending on how it is, and urban areas and so on. And then we have the human system, and in different regions and or countries, and the human system includes, and this is very important, demographics. So it computes itself how the population grows depending on how is the economy and the food and the amount, the necessary water, etc. And so it is complicated, but it's not horribly complicated. So we could at least try to, and we have some examples, show how the difference that including the interaction, the bidirectional feedbacks between the human and the natural system. And very, very importantly, it has policy. So the government or whoever is in charge decides how the policies, and people think the government cannot do anything. So I'll show you one example which makes me proud, because it shows that this is South America and this is Argentina, and you can see what it shows is the NDVI, the vegetation index, and red means that it's saturated with vegetation. And you can see that there is a little province here called Misiones, and that it's completely saturated, much more than very similar areas that are halfway depleted. And what happens is that this province of Misiones protects the forest. It has a very simple policy, and it's obviously successful. So, for example, 30% cannot be exploited of the forest, and the rest has to be exploited in a sustainable manner. And because they know that the forest is the main source of income, so they want to keep it healthy. So policies are very important. And what happens if we don't consider the fast way that we are growing and consuming what nature saved, accumulated over hundreds of millions of years? Could we collapse? And actually, I didn't know until I started working on this with more knowledgeable people that there have been many, like 500 cases of collapses in the last 5,000 years, and it has been studied in Europe, where I'll show you a little bit, that collapses are due to overrunning the carrying capacity, so consuming more than what nature and the whole system can provide on the long term. So we developed a human and nature dynamical model to start understanding the nonlinear feedbacks of the Earth, between the Earth and the human system. And we used a model which is observed in nature, the predator and prey model, and this is the Canadian foxes, whatever they are in red, and when they grow, the rabbits decrease, and then when the rabbits decrease, the foxes decrease, and so on. So this is a well-known model, and we thought, why not start with that for the human system? But for the human system, we usually believe, because that's what we have experienced ourselves, that human history has been a continuous and inevitable upward trend in levels of population and prosperity. And I felt it myself as I grew up and as I came to the US from Argentina. I saw that the average of prosperity was growing, but the historical record is like the oscillations, cycles of rise and collapse occur frequently, and we are not aware of that, often involving centuries of decline, and decline of the population, economic and intellectual. For example, we would lose the ability to read and write. And there were many collapses, and the Roman Empire, the Minoan civilization, the Mycenaean civilization, and I'll just mention what happened in Greece 2,000 years before Christ. The population, with a collapse, dropped by an order of magnitude. The urban areas were abandoned. Literacy was completely lost, and the recovery took 4 to 5 centuries, and that's typical of all the collapses, and there are many more, and not just collapses, but cycles of collapses and then recoveries. So, and same in the American continent, like the Maya civilization and many other ones. And the Maya civilization collapsed. Between 90 and 99% of the Maya population disappeared, and many others. And cycles occurred in early, even before agriculture, non-stratified, because agriculture brought social stratification also. The introduction of, in contrast to the assumption that we make that the population grows all the time, steady, boom and bust pattern appear with multiple cycles. And this is an example of this study that shows between 10,000 and 4,000 the population, and you can see that the population grew, collapsed, many cycles. And this is the best known populations about medieval England. And, and you can see this is the black pest. And that once somebody said, but that's not the growth and collapse, it's just a natural phenomenon because of the rats. But the rats were just a result of the social situation, the poverty and so on. So it is a natural, it's a result of the overpopulation. So the scientists that have studied say that collapse is a picture that appears again and again, and so the Russian scientists that have done a lot of studies about that. So we built this model, which has which is a standard predator and prey model, but we added two properties found only in the human populations. One is the accumulated surplus or wealth, and the other is economic inequality. And especially with agriculture, the beginning of agriculture, people could, for the first time, accumulate rice, for example, and whereas before eating animals, you couldn't accumulate it. So as a result of having accumulated wealth, economic inequality also appeared in the human systems after agriculture, and we investigate mechanisms. And the model is exceedingly simple. It just has 4 equations. And for example, this is the equation for nature. It has a nature equation and then a population equation which has rich and poor. So we didn't want to call them rich and poor, so we call them elite and commoners. So, for example, the nature equation says nature grows by a logistic equation y, which is proportional to y and saturates at the value lambda, and then it decreases by the production, which is a production per capita, depletion per capita d delta, and the population of commoners, because the commoners are the ones that produce, and it's also proportional to nature. And also there is a birth rate and death rate for both the commoners and the elites, and we put the same values here. So and we took normal values but then the important thing that we did is that the death rate has a healthy level. Let's say we all live at 275 or something like that, and that's this level. But when there is not enough accumulated wealth to give food or rice to everybody, then the poor start increasing the death rate until they reach a level of famine, no food, and the rich accumulated wealth, so they can still wait until they also run out of wealth, food, and the death rate that increases to famine. So when there is a crisis like a famine, the elite can spend their accumulated wealth to buy food and survive longer. And so it's like a stocks and our population, elites and commoners, and the nature and the accumulated wealth, and each one has sources and sinks. So we made an experiment assuming that we have an egalitarian society where the ratio of what the rich and the poor make is 1. So kappa is 1, so everybody makes the same amount of money, and then we get the optimal production of nature, and this is the population of the commoners, that are not the only people, and wealth, and it reaches equilibrium, which is the optimal thing, without including new technological advances, which is what you expect. So this is the optimal depletion per capita. So what if we increase the depletion per capita more, because for example, the elites want to have more money, then the optimal depletion is here, and if we increase the depletion per capita, then you start to have oscillations, and you reach a new equilibrium which is lower than that. And if you keep increasing you get cycles of almost collapse, and then it starts again. So the commoners almost disappear, and then nature recovers, and then the commoners grow again, and so on. But if you continue having stronger depletion above this value, then it just collapses, and nature disappears, and then the wealth disappears, and then the population dies.